Good day to all. We're going to continue with our second part for the video that we made for chapter 2, the hydrocarbons. Now is we are into cycloalkanes, and this cycloalkanes still part of our alkane hydrocarbon compounds that we made in our first video for chapter 2, as what I have said. But before we're going to proceed into the continuation for our discussion, let me remind you first of the work exercise for this chapter, that you can access or purchase your work exercise for this chapter 2, hydrocarbon compounds, by paying first at my PayPal account. The link of my PayPal account, I'm going to put it at the comment section, as well as my email address, so that after you paying your $1 to my PayPal account, meaning you are going to wanted to have a work exercise for this chapter 2, the hydrocarbon compounds, email me that you had already paid a $1 there to my PayPal account, and then I'm going to send you right away your work exercise. After working with your work exercise for this chapter 2 of the hydrocarbon compounds, send me your answered work exercises so that I could check it. And after, I'm going to check your work exercise with an answer of yours, of course, with your score and a corresponding explanation to all of the questions that I'm going to make for this chapter 2, hydrocarbon compounds. And the second reminder is, can you please subscribe to my channel? And the third one is to make a comment down below. All right, so you can hear my voice is very loud. This is me, my normal voice. I talk very loud at the when I'm going to teach at the classroom, but I'm trying to, slow down with my voice, and I hope that this would be okay with you. All right, whatever's my voice is, our purpose here is to learn. Okay, now let us proceed to our tutorial. So, the last part for our alkane hydrocarbon compounds discussion is the cycloalkanes. What is a cycloalkane? Cycloalkanes, we may begin at any position and may proceed either clockwise or counterclockwise, but we must end up with the lowest possible numbers. So we're talking about the location of the carbon atoms in the position present in the structure. Okay, so I have here an example for the location of the carbon atoms present into the structure. So from the word itself, cyclo, so meaning circle, right? Okay. So our structure is very obvious. It should be round, not round. It should be closed, cyclo. And we may begin at any position, meaning any corners of our structure. We can assign into that corner as our first carbon atom. We've been talking about at what side are we going to assign our first carbon atom, either into this end or into the other end. We will assign our first carbon atom into the right end if our groups or branches is nearest into that end, into the right end. Or we can also assign our first carbon atom into the left end if our branches or groups is nearest or being attached near to that end, right? Okay, now into the cycloalkanes. What we are going to consider here is we have to make it sure that our first carbon atom is into that corner that has a branch. And if it doesn't have a branch into our cycloalkanes, then you can assign your first carbon atom at any corner. And then either you're going to proceed it clockwise or counterclockwise, doesn't matter because you don't have a branches. And if only you are going to consider what direction, whether clockwise or counterclockwise, you are going to consider that direction only if you have branches attached to your parent chain. What is a parent chain again? We talk about what is a parent chain. right? And what is a parent chain is a longest continuous chain of the carbon atoms present into that structure that we are going to give name or identify what's the name for that structure of the alkane compounds, hydrocarbon compound. Now here for the cycloalkanes, again, I keep repeating my words, but I want you to understand fully that we're having this tutorial is what's the purpose? Is for you to be able to understand. Okay, cyclo meaning your structure is closed. Alkanes meaning this is a single band. The structure of your hydrocarbon compound bears a single band, but in a closed ring structure, not straight, open. All right, so here we go. And this structure that I give you has a branch. And what's the name for that branch? Is a methyl group. So therefore, where this methyl group is attached to, into that corner, every corner of this structure represents a carbon atom. The methyl group is attached to, into that corner, represents our first carbon atom. Why? Because there is no other group that is attached to our parent chain, this closed ring structure. You have only one group, and what is that? This methyl group. Therefore, that corner where your methyl group is attached to is automatically become our first carbon atom. And then you can proceed assigning your corners that represents your carbon atom either clockwise or counterclockwise. Doesn't matter. Why? Because you don't have any other group or branches that is attached to those corners that we are going to identify, right? Only when there are more than one. So since in this case we have only one group or branch that attached to our parent chain or the mother chain. And what is again? The name is methyl group. So you have methyl group is attached into corner into this carbon atom, followed by going clockwise, or we can also go this way, counterclockwise. So to name this structure, we have methyl, you mentioned first as our prefix, the group or branch that attached into our parent chain. And what is the name of that? Is the methyl group. So methyl group, we have this prefix methyl. Since the shape of our structure is closed, then therefore we're going to take the prefix of our word cyclo. So after naming as part of your prefix the branch that attached to our mother chain, which is the methyl group. So methyl, this one, cyclo meaning your structure is closed. And for how many carbon atoms do we have present in this structure? We have 5 carbon atoms, okay? Meaning 5 corners, that represents 5 carbon atoms. So the name for this structure, our first example is methyl for this group that is attached to our parent chain. And the shape of our structure is closed. Then we have this also word cyclo. And a total of 5 carbon atoms for the 5 corners is, if we have 5 carbon atoms, what is the prefix? Pent. And since we have only single band, now you can see here, it's only single band. So therefore, our suffix for our prefix pent is A-N-E. That represents, meaning you have only single band present into the structure. So this is methyl, cyclo, pentane. The second example now, here we go. This is what I told you. Not only that we have one group or branch that attached to our parent chain, there are 2. So in this case, and what kind of branches or groups? We have same groups. And what is the name for that group? Groups is methyl group. So there are 2 methyl groups attached to our parent chain. How many corners do we have in our parent chain? Represents the number of carbon atoms, represents the carbon atoms for every corner of it. Is we have 6 corners, meaning we have 6 carbon atoms in a closed ring structure. So therefore, we have, what is the name of our parent chain? The prefix is hex for having 6 carbon atoms, right? And then how many branches do we have attached to our mother chain, having 6 carbon atoms in a closed ring structure? 2. What is the name of that group or branch? Groups or branches? Methyl groups. Same. So what we're going to do is, either way, in this case, if you're going to assign your first carbon atom into this first branch, this is a methyl, right? And then you can go this way. Why we need to go this direction? Why not on the other direction? It's because if we go to the other direction, the second branch becomes attached to the large number of your carbon atom. Remember the general rule on how to assign your carbon atom number. It should be that the group must attach to the lowest number of your carbon atom. So therefore, we have to consider going this way, counterclockwise. Because if we go counterclockwise, the second carbon atom goes to the largest number of your carbon atoms. So let us go, we're in that branch, the second branch, make it sure that it attached to the lowest number of your carbon atoms. So if this is our first, then we go this way. Meaning, if we go this way, that second branch attached to the third carbon atom. Let us check if we go the other way. What second branch will attach to what number of carbon atom? It becomes, if this is the first, becomes this is your second corner, third corner, fourth corner, fifth corner. So therefore, your second branch becomes, it will attach to the fifth corner. That, which one is the longest number, the 3 or the 5? Of course, 3 is the shortest, 5 is the longest, right? So therefore, we have to consider the 3, not the 5. No, that's why we have this direction of assigning our carbon atoms clockwise. So then, to name the structure, since we have already assigned the number of our carbon atoms, 1, 2, 3, 4, 5, 6, to name the structure, our prefix first is to name the groups or the branches that attach to our parent chain. What are those if we have more than one? In this case, we have more than one. We have 2. And what is the name of that branch or groups that attach to our parent chain? Is the methyl groups. Are the methyl groups attached to what carbon atom number? 3, 1, and 3. So to separate two numbers, you're going to use the comma, right? So you have 1 and 3 for the first methyl attached to the first carbon atom, 3 for the second methyl attached to the third carbon atom. Dash to separate a number and the name of the group or branches. And what is the name? Since you have 2, you're going to use prefix di. The name of that branch or branches or groups is our methyl groups. So that you have 1,3-dimethyl. Since this is a closed ring structure, we will take the prefix word cyclo. And you have only single band present to this structure, meaning we are going to use the suffix ane. But for how many carbon atoms do you have? For how many corners do you have for this structure? 6 corners represents 6 carbon atoms. So if you have 6 carbon atoms, what is the prefix? Hex. Plus, being a single band, ane, the name is hexane. So you have the name for this structure, 1,3-dimethyl cyclohexane. Okay, another example. What if our structure has a lot of the same branches? So why I am having this kind of example class is for you to be able to identify or to know on how you can assign carbon atoms to your closed ring structure. Now in this case, you have plenty. And sometimes you see this in one corner, you have 2 branches or groups attached into that carbon atom. So for you are going to identify 2 groups, meaning you are going to mention that carbon atom number twice. In this case, you have 2 groups. And at what carbon atom number is attached to? For these 2 groups, the bromo into first carbon atom. So automatic, that corner represents that carbon atom is your first carbon atom. Why? Because you have 2 branches or groups that it attached to. So that's your priority. Carbon atom that has more than 1 branches that is attached is your first carbon atom. But if you have only one, is your priority is that carbon atom wherein it has group attached to is your first carbon atom. Okay, then the next priority is if you have more than two, make it sure that your second carbon atom is nearest to your first, the next group, the second group that attached to your parent chain, make it sure that it is nearest to the first group that wherein it attached to that carbon atom. All right, is that clear now? Okay, let me refresh. Now make it sure if you have only one group or branch attached to your closed ring structure, it's okay. It's very simple, easy. That corner that represents a carbon atom, automatic is your first carbon atom. You can, and then followed by going your way on counterclockwise or clockwise. But what about if you have two branches or three branches attached to your parent chain? You just make it sure that your first group is nearest into, but this is a cycle, no? So doesn't you're not going to consider what end, because there's no end. This is a cycle, closed ring structure. So if you're going to choose, you have to choose a side wherein it has a lot of branches that attach to that side. Now in this case, you have two groups attached to this side. Therefore, your first carbon atom is either into this side. Either this side is your first or this side is your first. And then make it sure, followed by make it sure that your next group is nearest to the first group of where that first group attached to that carbon atom. Okay? So you have, make it sure that your first group is nearest to the second group, or that the second group is attached to a carbon atom wherein it is nearest to the carbon atom where your first group is attached to. Okay, I think that's the right explanation. You can understand that one now? Okay, let me give you a clear explanation. Another explanation. I hope you can understand. Well, because our purpose is tutorial for you to be able to understand. Now, what happened? This is a closed ring structure, right? We have to make it sure that our branches are attached to the nearest or the lowest possible number of the carbon atom. What does it mean? If we have two branches, it is easy. For example, okay, let me refresh. If you have only one branch attached, it's easy to, assign numbers. You have only one, the methyl group. Easy to assign numbers. That corner is your first carbon atom, right? You don't need to consider. Right away, assign your first carbon atom there at that corner. And then next is, what about your second carbon atom? You can go either way, clockwise or counterclockwise. Why? I say that. There's nothing for you to consider. There's no other branch that you are going to consider. That other branch attached to your parent, nothing. You have only one. So you can go either way, clockwise or counterclockwise. Now, what about in the case of you have more than one branch? You have more than one group that is attached to the parent chain. This is, you are going to consider a little bit. No, not right away. If you have two branches, here, let me see this one. Okay. So, and let us use again methyl groups for our example purposes, demonstration purposes. Now, you have those two branches attached to your parent chain. How many corners do we have? 6. Okay, so therefore, the prefix for our parent chain is hex, having 6 carbon atoms. And into this closed ring structure, you have only single band. Therefore, if you will have a suffix A and E, so meaning our parent chain is hexane. Being a closed ring structure, we can take, no, not we can, we have this prefix cyclo. Okay, so, right. Cyclohexane. Okay, let us consider now our prefix. What is our prefix? We have to identify first as to what carbon atom is our first carbon atom. You have two branches. Consider these two branches. You can assign either that corner, either corner, no? Either this one is your first carbon atom or this one is your first carbon atom. Let me use another ink here. Either this is our first carbon atom or this one is our first. Doesn't give us a color, alright? Okay. No. Okay. So be it. Okay. Either this corner is our first carbon atom or this one is our first carbon atom. Doesn't matter. What I mean is assign right away your first carbon atom, wherein it has a branch or group that attached to that corner. So if, for example, this is our first carbon, you want this corner as your first carbon, it's okay. You can assign that as first. The next is a tricky one. Why I say this? Because since we have two groups attached to our parent chain, after assigning your first carbon atom, consider your second group, the next group, aside from this first group that you have assigned, that wherein attached to your first carbon atom. You think that this is your first carbon because you have this. Okay, sure, you're right. Now, the second step that you're going to do is the tricky one. Why I say this? Make it sure that the second group is being assigned to or being attached to the smallest, the lowest carbon atom number. And how are we going to do that? If we go this way, check all directions. If we are going to go clockwise, this would be your second carbon atom in this corner, third carbon atom for that corner, and this is your fourth carbon atom, and this one where your second methyl group is attached to becomes attached to the fifth corner. Fifth carbon atom for the fifth corner, right? So that's your second group, methyl group is attached to the fifth carbon atom. What about if you're going to consider the other way, the clockwise? So this one, if this is our first carbon atom, then therefore this one is our second and third and fourth, fifth and sixth. So okay, now consider which one has a lowest number, the 5 or the 3, where this group is attached to. Lowest. The general rule is always consider a group that attached to the lowest possible number of the carbon atoms. So you have 3 is the lowest compared to the 5. Therefore, you are going to go the clockwise. We're in this 1, first corner, 2, 3 for the second corner, 4 and 5 and 6. So to name now the structure, this is 1 as our prefixes, and you have 2, the next group. Methyl also attached to the third, 1, 3 dash the name of the methyl group. There are same groups attached to your parent chain. Therefore, if you have 2, the prefix is di. And what is the name of that group or branches attached to your parent chain is methyl. So you have 1,3 dash di methyl cyclohexane is the name of this structure, right? So is that clear to you now? Okay, thank you. Now next is we have the second example. In the second example, you have a lot. How many? 4 branches. And what is the name for that branch? Is bromine or the bromo. Okay, to identify what corner is our first corner for the first carbon atom. Consider that corner if it has more than 1 groups that it attached, where into that carbon atom has more than 1 group is attached to. So in this case, this corner, you have 2 branches, 2 groups attached, the bromine groups attached to this corner. So therefore, that corner is automatic your first carbon atom. The next that you are going to consider is the group, the next group. We have to make it sure that that next group will be assigned to the smallest carbon atom. So if we go, this is our first, then the next corner, second, the third. So therefore, this next group is attached to the third. And then continue numbering your corners for the corresponding carbon atoms. The next group is attached to the sixth group. Now, what about if we go the other way around? We had this, if this is our first, then the next 2, 3, 4. So which one are you going to consider? The 3 or the 4? Of course, we go to 3, which is lower than the 4. So that's why we have this direction. You have 1 for this corner, 2, 3, 4, 5, and the second group attached to 6. Since they are of the same group, so we can identify them as their numbers. Not that we're going to separate the number, the name of the group, and then the number, the name of the group. No, since because they are of the same, we can name all the numbers first, where these groups are attached to, then followed by how many of them, and then what's the name of that group, and then the last one is the name of the parent chain. Now, in this case, you have 2 groups attached to your first carbon atom. So therefore, you mention twice that number of carbon atom, meaning you have 2 groups that attach to into that carbon atom. So you have 1, 1 that represents 2 bromine group. And the next bromine group is attached to the third carbon atom. So you have 1, 1, 3, and the last is attached to 6th carbon atom. So you have 1, 1, 3, 6, and how many total of them? 4. So you have tetra, represents 4 groups, same groups that attach to your parent chain. What is the name of that group or branches? Groups or branches that attach to your parent chain is bromo. And then since your structure is a closed ring structure, we are going to take the prefix word cyclo. And then having how many corners? That represents the number of carbon atom, 8 corners. So meaning 8 carbon atoms. So what is the prefix if you have 8 carbon atoms? Is oct. And what type of band that is present into your structure is a single band. You have only single band there. So therefore, what is the suffix for oct prefix of the name of your parent chain? Is ane. So what is that? It's octane, right? So name, to complete the name of the structure, 1, 3, 1, 1, 3, 6, tetra. Tetra for having 4. What is the name of that 4? Same group, bromo. And then closed ring structure, cyclo. Oct for having 8 carbon atoms. And an is the suffix, octane, because you have only single band there. Alright, now that's the next example is, what if you have 2 different groups? Now, the same as in our open chain structure. But in here, you have to make it sure that we will follow the alphabetical order because different now. In this case, it's different. So which one comes first? The bromo or the methyl in the alphabetical order? It's the bromo, then followed by the methyl. Bromo is automatic being attached to our first carbon atom because that is first in the alphabetical order. And then make it sure that you see your second group is attached to the lowest number of your carbon atom, which is what is your next second group is the methyl group. So that's why the reason why we go this way for the assigning of numbers of your carbon atom. Because in this way, your second group, the methyl group, is nearest to your bromo group. Alright? Where your bromo group is attached to that first carbon atom. So to name this structure, this is called 1 bromo. Why? Because your bromine is attached to your first carbon atom. 3 methyl. Why? Because your second group, the methyl group, is attached to the third carbon atom. Cyclo, meaning you have a closed ring structure. And prefix cyclo. And the total number of carbon atom present into your structure is 6. You have 6 carbon atoms and you have single band into this structure. So therefore, your suffix is ane. So cyclohexane. 1 bromo, 1 dash bromo, 3 dash methyl, cyclohexane. Okay? Now, for the preparation of alkanes, first is we have this decarboxylation. How to prepare or make an alkane compound is called first decarboxylation. What is decarboxylation? It's a replacement of the carboxyl group. So in our first chapter, we have carboxylic acid group, right? In here is we have carboxyl group. So without hydrogen, you have only COO without hydrogen. If you have hydrogen here, this is carboxylic acid. Since you don't have the hydrogen, so this is carboxyl group with a catalyst of a salt of organic acid. And what is that salt? Is the soda lime. Soda lime is a mixture of sodium hydroxide and a calcium hydroxide. Is being used as the carboxylating agent, your catalyst. Now we have the general formula for this decarboxylation of your alkane of a salt, which is the soda lime, which is no, not soda lime, it's your sodium acetate. Okay, sodium acetate plus your soda lime, sodium hydroxide will yield alkane plus sodium carbonate. Okay, sodium acetate plus the soda lime, this is the general formula, will yield alkane and a sodium carbonate. Example in the preparation of methane. Now, for example, our product is methane, your alkane hydrocarbon compound. Our product is methane. How are we going to produce methane? In the preparation of methane gas, sodium acetate is being used as our catalyst. Is being heated with soda lime, your sodium acetate. Now this is the structure based on from the general formula that we have. You have sodium acetate. Why acetate? Sodium plus 2 carbon atoms. So this is the prefix as you have ethane. So since you are this is ether. So acetate. We will talk about that in the next chapter. But let me just tell you right away, okay? I'm not going to discuss here as to why we come up into this. We will talk about how we come up into this structure as an acetate, as whatever. But for the sake of the preparation of alkane and the decarboxylation of your acetate, your ester, will yield plus a catalyst, your soda lime will yield an alkane. In this case is methane. What is the byproduct? Is the sodium carbonate. So your sodium acetate, the sodium and the carboxyl group will combine to your sodium oxide, forming sodium carbonate. What are left is the CH3, your methyl group, your alkyl radical group, will combine with one hydrogen atom that was present into your soda lime, the sodium hydroxide, to form a methane group or methane compound. So again, in your sodium acetate, the sodium carboxyl group will combine to your sodium oxide that is present into your soda lime to form into sodium carbonate. What are left? Just copy what are left. You have CH3 from your sodium acetate plus one hydrogen atom from your soda lime will form methane gas. The second preparation or reaction. Second reaction for your alkane and the cycloalkane hydrocarbon compounds is through combustion. In combustion, you have two processes. Complete combustion and incomplete combustion. Okay. In the complete combustion, just follow the general formula that we had. What is the general formula of an alkane? Complete combustion of your alkane. What is the general formula for alkane? CnH2n plus 2. Can you see? All right, I think so. Okay, CnH2n plus 2 plus, we're talking about combustion. If you have a presence of oxygen, there is a fire, right? So plus oxygen. And then we'll yield carbon dioxide plus water and will produce plus heat. All right, okay. Now to give you an exact, clear example as to what kind, for example, for our alkane, we have CH4 as our alkane CnH2n plus 2CH4 plus the oxygen will yield carbon dioxide plus water that will evaporate as heat. Okay, this is the heat plus heat. So that is the combustion of an alkane compound, complete combustion. What about for the incomplete? Again, let us take the general formula of your alkane CnH2n plus 2. For example, we have again methane, the CH4, incomplete combustion, plus oxygen again, combustion represents for the combustion, oxygen will yield. Here you have carbon dioxide for the complete. Now for the incomplete is carbon monoxide. Plus you have same thing as water. And what are the other products? You have either an acid. You have the acid is, this is a structural formula. I can give you COOH plus water.